Okay, so let's begin with another MCQ which is previous year, which has been asked in 2008 for 2 marks. So vertical rod PQ of length L is fixed at its top end P and has flanged fixed at to the bottom end Q. A weight W is dropped vertically from a height H which is less than L onto the flange. The axial stress in the rod can be reduced by. So basically here they are asking a relationship of axial stress to the other parameters. So you can see the options: increasing the length of rod, decreasing the length of rod, decreasing the area of cross section, increasing the modulus of elasticity. So it is basically formula based question. If we know the formula, then we just have to find which quantity is directly proportional and which is indirectly proportional. So just we have to find out the relationship. Okay, but before that, let's draw this question what they have given. See, I am here drawing. This is your rod, that is your PQ. Okay, so this end is P, this is Q. Here some flange is attached. Okay, so here you can see this is your flange. Now the length of the rod PQ is capital L. Okay, and this is fixed, this is flange is also fixed, upper end is also fixed. Okay, so whatever deformation will occur, it will occur in this region PQ. Now see, they are telling that some weight is, you are keeping one weight at some height H and you are making it to fall from height H. Okay, so this weight W will be falling from the height H, which is obviously less than, H is less than L. Okay, so now what will happen? Because of this impact, see, this is a clear case of impact loading. Okay, here we are not entering into that section whether it is gradual loading or sudden loading or impact loading, but still let's understand that it is a case of impact loading where a weight is dropped from a height H. Okay, now due to this impact, what will happen? Kinetic energy, that is half mv square will be generated, and this ultimately it will be converted to strain energy. It will get converted into strain energy, right? So now basically we have to write the formula of strain energy. So strain energy, you know, U is equal to half stress into strain into volume. Okay, so half sigma, strain is epsilon and volume is area into length. Again I can write 1 by 2 sigma, strain is stress upon Young's modulus, that is sigma by E. So basically it will be sigma square by 2E, E into L. Okay, this we know. Okay, now see, they have not asked us the relation between strain energy. They are asking the relation between the stress as well as area or stress and length of the rod, or stress and elastic modulus. Okay, so here we know that axial stress sigma is inversely proportional to area by this equation. Stress is again inversely proportional to L, but stress is directly proportional to E. These three things we know from this equation, because they are asking the relation between stress and area, stress and length of the rod, and stress and the value of E. So these three things we know. Okay, so just we have to see the options now. Here axial stress in the rod can be reduced. Now we have to reduce. So what will happen? Increasing the length of the rod. So here I am reducing, so increasing the length. So this condition is satisfying. Okay, so option A is true. Okay, so but let us check for other options also. So decreasing the length of the rod, obviously if one is A is true, then B is wrong. Decreasing the area of cross section, so here it is wrong because they are inversely proportional. Okay, here we are reducing the axial stress. Again third, last, increasing the modulus of elasticity of the material. So now it is directly proportional. So this is also wrong, because axial stress in the rod you are reducing. So basically it will reduce by a modulus of elasticity. You have to reduce that quantity also. Both are directly proportional. So answer is A.